Howdy team, and welcome to the last of our videos about looping. And in this video, we are going to talk about while loops. While loops are our indefinite loops where you don't necessarily know at the time that you start executing how long you're going to need to execute the loop. It is unclear, and it's usually based on some sort of calculation or some sort of new data that you're getting in. You can't just say this is going to execute 17 times because maybe it's only going to take 12 times. We don't really know. So to do that, we use what's called a while loop. So the one we talked about before used the for keyword. And now we're talking about the while loop, where while is the keyword. So a while loop is going to repeatedly execute the statements inside its body. Remember, the body is anything between these curly brackets. So it's going to execute the body as long as the logical test here is true. This is going to be some sort of Boolean statement. So long as that Boolean statement, the value of that statement is true, it's going to keep looping. Once that statement is false, then it will no longer execute the statements and it will move to whatever code is beyond this curly bracket. So if you were to think of a flow chart of how it works, we go in, is the test true? If yes, we're going to execute the statements and go back and check the test again. And if it's true, we're going to execute the statements. If it's not true, we're just going to move to after the while loop and start executing down there. So this is unlike the for loop. You can see we don't have any variable initialization up here, nothing required. We also don't include an update step. There's no mandatory update step. It is expected that somewhere in these statements, you're going to update or change the conditions surrounding whatever this Boolean statement is, so that at some point, the Boolean statement will end up being false. It is possible to write a function or write a while loop such that the test, the Boolean statement here, is never false. And if it's never false, then it's what's called an infinite loop. It's just going to go on forever and ever and ever. So here is an example. We're getting the number, a num, from the user. So we're just getting a next int there. And we say, while that number is less than or equal to 14. So if num is less than or equal to 14, we're going to say, hey, this num isn't less than 14 yet. And then we're going to multiply it by 2. So we are modifying this num value here. And then we're going to go back up and check if our num is less than or equal to 14. Okay, let's check that. So we have this function here. I've added just a couple more statements, a little bit of what we call logging. So we're printing things out to the screen. I'm also closing the scanner. That we didn't do that before. And we also didn't print out at the end what our final value of num is. So that's all that I've added. This here is the same code as before. So you can see again in this code, we are getting the value of num from the user. It's going to be an integer. And while the number is less than 14, we're going to say, hey, this isn't less than 14 yet. And then we're going to multiply it by 2. And then at the end, we're going to print the final value of num. So when I run it here, it says, please enter a number. I'm going to enter 9. And it's going to say 9 isn't less than 14. And so inside, it's going to multiply num by 2. So we're going to end up getting 9 times 2 equals 18. And then it goes back to check this value. Num is 18 now. So it is not less than or equal to 14. So we exit the loop and move to execute this code here. Okay, let's look at another question. This one I want you to try to answer. Tell me what the output of this is going to be. I mean, you can't really tell me because this is a video, but pretend you can tell me, pause this video, come up with the answer. Okay, I think you're back. I hope you tried this question and came up with an answer. It looks like we have some promising things here. Maybe it's 1. 32 looks promising because we're multiplying by 2, so we're always going to get a factor of 2. So those look promising. I don't know. Let's run the code and see what happens. So here we have our mystery while. This is all the same code as it was before. So I'm going to run it. Let's see what happens. Nothing is happening. Nothing is happening, but I can still see there's an X here, so it is running. It's just not running. It's not giving us an answer. I'm going to stop it before it takes up all of the processing power on my computer. And you can stop it using that X button like I just did. If I had kept that running, my computer, the fan would start getting really loud. And it would just keep going forever and ever. This is what's called an infinite loop. Let's talk about that. So we start with X equals 0. I think X is what we're going to keep incrementing, or we're trying to make X bigger until we get to some sort of limit. So what this code is doing is it is finding the closest power of 2 that is greater, the first power of 2 that is greater than our limit. So we have our value, we're going to start that at 1, and we say, while this value is less than the limit, we're going to take X and we're going to multiply it by 2. But the problem is, there's a couple of problems here. One, X starts at 0, so when you multiply it, it's always going to stay 0, because 0 times anything is 0. So when we take X times equals 2, that's always going to equal 0. It's never going to change. Another issue here is that we are modifying the value X, but we are not modifying either val or limit. And these are the variables that are using in the test for the while loop. And since they aren't changing, that means that this is going to evaluate to true every single time. We don't want it to execute every single time. We do want this to change at some point. So right now it is infinite looping. It's just running forever and ever and ever. And the only thing it's doing is taking 0 times 2 again and again and again and again. And that's really not helpful. So if we were to fix this code, we would replace that X with, think about it, what value? We would want to increment it, or we would want to update val by 2, because it is val that we want to keep track of, because, I'm pretty cool. And that means that we don't need this X. And now, if it executes, we should end up getting the first value, the first power of 2 that is greater than 60, which should be 64. Great, that's what we get now. Just so that we can keep track of what's going, let's write val inside here so that we can keep track of how it's looping. So we get 1, so val equals 1, that is less than the limit. Then we get val equals 2, which is still less than the limit. And we keep increasing by 2 until we get something that is not less than the limit. That's the 64. And so after that, we exit the loop. And then here, we're just printing out that last value. So we took what was a infinite loop that had multiple issues with it, and we have now turned it into something that makes a lot more sense and isn't going to continue running and running and running on your computer. If you end up getting a lot of infinite loops and you start hearing the fan of your computer getting super loud, there are these buttons down here that you can use. This one is just going to remove the current launch. So the current thing that I ran, you can see I didn't have any others that were still running at that time. But the double X is going to erase all of them. And if I still had a program running, maybe it was waiting for console input, or maybe it was infinite looping, it would show that to me and I would be able to close and cancel it, even if it wasn't the very last one that you executed. So if you're starting to hear that fan on your computer, check this, terminate everything that you can. Okay, let's talk about another helpful kind of while loop, something that you're going to see frequently. So when you're getting user input, often you need to use something called a sentinel value. So a sentinel is some sort of value that signals that the user is done entering their input. They don't want to enter anymore. And a sentinel loop operates on that sentinel value. So it's going to keep looping until that sentinel value is what we expect it to be. So let's say we wanted to write a program that's going to prompt the user for text until the user doesn't type anything at all. And then it's going to output the total number of characters. So basically, we're going to let the user keep typing things. When they type something, we're going to record the number of characters. And as soon as they type nothing, then we can stop. And we uh, tell them how many characters they typed. So let's write that together. I have started that here. Basically, all I've done is open a scanner and close the scanner. So we know that we need to keep track of characters. Let's create a variable, an integer num characters. We numchars is enough. And we haven't seen any from users yet, so I'm going to implement or initialize it to have 0 or to start with 0. Now we need to have a input of some kind. We need a value that represents the user's input. So let's say input equal, input equal, I should call it a string. That's probably why it did weird things. String input equals what do we set it equal to? I don't know, just a space for now. We don't really know. We know we need this variable. We don't know what we're going to use it for. We can come back and edit it later. So let's just leave it at a space for now. And let's see, what do we know we need to do inside this loop? We know we need to loop stuff. So this is going to be the while, and then it has the test. And then inside that, we need to get user input and count the chars. And so long as we know, remember, we know we can stop when they enter nothing. So when they enter the empty string. So we know we want to loop until input is the empty string. Okay, so if that is what we need to do, that's the loop. Afterwards, we need to add we need to print out I'm reading this from the slide on my other screen. You typed a total of plus numchars plus okay. So then we close. We're all good. All right, let's start filling in these comments. I like to add comments like this just to organize my work. I know what needs to happen. This is kind of like writing an outline for an essay before. Most of the time, I just write it on little scratch paper or I'll write it in comments like this. So let's add this actual code here. We know the keyword is while, and we need to add something in here, loop until input is the empty string. So I know that I need input, and can I just do this question mark? I hope you remember from our previous classes that you cannot compare strings like that. So there are a couple of ways that we can determine whether input is the empty string. We could say input dot equals, and we can include the empty string there. Another thing that we could do is we could say input dot length equals 0. Either one is going to tell us whether we have the empty string. I'm going to keep it at input.length equals 0 because this is going to be slightly faster. It's going to be slightly faster to run. We're comparing integers instead of having to go through and look at each character in the string. So we have this while loop, and I'm going to open some brackets so I can add the body. Now it says get user input, so I can say, I'm reading this again from the other screen, type a line or nothing to exits, and then colon and a space. So we've given the user an instruction, and then I'm going to say input equals, I'm going to use our scanner that we created up here, scanner dot next line. So now we've gotten the user input, which is great. We need to now count the chars. We have numchars here, and this is the value we know we want to add. We need to modify it. So I'm going to say numchars here, and it needs to, what does it need to do? Think about it. What do we need to add? We need to add however many characters of input they provided. So here we're going to say numchars plus equals input dot length. Okay, so let's just review our code before we run it, make sure it makes sense. So we create the scanner, that's fine. We say numchars equals 0, makes sense. The user hasn't entered any. We come up with some sort of string input. Here I'm using a space. We could use anything, that's okay. So we're using a space and we're saying then while the length does not equal 0. Well, the first time we have a space, so the length of that is going to be 1. It's 1 character long. So we're going to enter the for loop, which is good. The length is greater than 1 or not equal to 0. Then we're going to get some user input. They're going to give us some information, and then we're going to increment the number of chars that they've input. This is going to continue and continue and continue until the length that the length of the string they provide is 0. And then after that, you're going to say you typed a total of however many characters. We close the scanner, program is done. Let's run it. So, what did I do wrong, team? Did you notice this as I was writing it? I didn't, but I am saying while the length equals 0, we're going to keep looping, and the initial input did not equal 0. What I really want it to do is while the input does not equal 0, we want to do the looping. So I was doing the wrong test. Was that like bugging you as you were watching this? Maybe. Okay, so we're going to run. We're going to type a line. It looks like I did println instead of print. That's fine. I have a dog. Her name is Pixel. She has allergies and is very itchy. And then I'm going to push enter again, and it should finish. You typed a total of 65 characters. And I'm not going to go in and actually count them. You can if you want to. I'm going to trust that it is actually 65. So here, what we were doing, again, let's go back to the sentinel. The sentinel value was an empty string, and we were going to loop until we got the empty string, until we got the sentinel value. So remember, this is equal to or equivalent to input that equals empty string. It should have the same impact. I did it again. It's really, we want it while it does not equal. So I can just add the not sign outside of this expression here, and it's going to invert it for me. So now it's going to say type a line, hi, hello. We should get 7 at the end. You typed a total of 7 characters. So we were waiting until we got the empty string. Cool. Now, what happens if instead of the empty string, we wanted a specific word? So the user can enter quit to answer or to enter. So we're changing it, input equals quit, and then now the user has to enter the word quit in order to exit. So instead of the empty string, again, we're just looking for the word quit. Everything else is going to run the same. Let's run it and see. So now I can say hi and hello. And okay, now I'm done. Wait. So it should have here only shown, we only intended for 7 of those characters to be counted. We did not want, like, the characters in quit are also being included in the input length. Interesting. So what do we do here? This looks like a fence post problem to me. Fence posts can exist in while loops too, and indefinite loops. So what that means is we need to pull out a fence post. Let's first think about what is the post and what is the wire. What is the thing that is going to be on the outsides and what's going to go on the inside? So it seems like this calculation is what's on the inside. We're going to have more um, input than we are calculations. So we need to pull out one of the fence posts to the outside of the loop. So I just copied that with Control C, Command C, I have a Mac. And I'm pasting it out here. So we're saying type a line or quit to exit. Then I'm going to get some input. I no longer need to say that my input is an empty string. I can get rid of that. So I can say now type a line or quit to exit. I get the input from the user on the outside of the loop just for the first time. And then I can check to see, does the input equal quit? We don't know. Now, the way it's written right now, it is like add a post, and then some wire, and a post and some wire. We need to have the wire in the middle. So we need to increment numchars before we get another piece of input. So now we are at a post, add some wire. And this again is add a post. So that at the end we have post wire, post wire, post wire, and we end with a post. And then it says you typed a total of some number of chars. This guarantees that we do not count the chars when the input equals quit, because when it equals quit, it's just going to exit the program, or it's going to exit the while loop, and those chars are never going to be counted. It's not going to enter the while loop and get those chars counted. I may have made a mistake. I don't know. Let's run it. I am human and make mistakes all the time. You've seen me do that multiple times in this video. I'm going to type a line. Hi, hello. Remember, we're hoping to get 7 chars. Now I guess 10, if I can spell things correctly. Yes. Okay, so now we typed a total of 10 characters. So the 10 include the hi, the hello, and the whatever this is. It does not include this. I technically typed 14 characters. It did not include the characters in the word quit. So that is how we were working with these Sentinel values. There are a couple of like stinky things in this code. I'd like to clean it up for a minute if you would allow me. So we're using some sort of like magic numbers and magic strings here. So first I want to create a string, and I'm going to call it Sentinel. I don't know why it does that every time. Okay, so string Sentinel equals, we said that it was the string quit. Okay, so now I think I probably want to make this final, which means it's going to want me to put this in all caps, Sentinel. So now here, while input dot equals, I'm going to add Sentinel here. So if we were to use this multiple places, it would always change. See here, we're also adding it. So I am going to say plus sentinel. So this way we're always using that. I'm going to fix this one. I'll just do this. Knew it couldn't be that easy. All right, I'm going to run it again. Everything should be great. It is working. Everything's fantastic. We're still printing out quit the way we should. But there's another thing that is bothering me. We have the same string being created twice, and I just don't like that. So I'm going to say final string prompt. We have to do it in capital letters. Prompt equals this. So I'm going to add a semicolon at the end there. And now when we print it, I am just going to print capital. Capital prompt. And here we are going to print prompt. So we know that it's always going to be the same. Let's run it again just to make sure. Type a line or quit. Hi, hi, hello. Should have 9 characters. Quit. You typed a total of 9 characters. So it is still working. It is just a little bit less stinky than it was before. It'll be really easy now if we wanted to say instead of quit, we are going to make it bananas. So I can type a line or bananas to exit, apple, pear. Makes it really flexible so that I don't have to change things all over the code. I'm able to just change it one time in one place and everything now works. So that, my friends, is the while loop. Let me go into my slides and make sure that I have covered everything. All right, I think I have. That leads us to the last question. So I'll let you see this on the slides. You are going to pause the video and let me know what you think the answer is. Try to figure it out. Pause. Okay, let's see. So of course, I have this as a program here. So we have int x equals 3. We're starting with 3. While x minus minus, that means we're going to use the value of x and then we're going to decrement it. So while the current value of x is greater than 0 and 3 is greater than 0, you can think of that x minus minus happening just outside of this. So it's like the first line in the while loop. It's basically what it's doing. So inside, x is going to now change. It was 3, and now it is going to print out whatever the value is. In this case, it's going to print out 2 because we used the value as 3 up here, but we decremented it. Now it's 2. So it's going to system.out print 2. Then it is going to go up here again. 2 is the value, less than or equal to 0 is true. So we are going to print the new value because we decremented x. That's going to be 1. Great. We're going to go up here. 1 is still greater than or equal to 0. We decrement it right after using it. So this value of x is going to be 0. We now check it one last time. The value of x is currently 0, which is less than or equal to 0. We decrement x, and then we print out -1 here because we have decremented x that happened after we did the check. So we do enter the loop when x equals -1. Like at the end of this statement, x is going to equal -1. So I think we are going to get 2, 1, 0, -1. 2, 1, 0, -1. All right, team. This has been a long exploration into loops. I hope you've enjoyed it. Again, please let me know if you have any questions. I will make sure that all of these files that we've worked on today are included in the course GitHub for class demos. And I hope you have a great day. Goodbye, team.